Okay, 2.8, equivalent expressions. This is actually not too bad. Okay, so let's see. They've got a couple of different figures here. All this is saying is there's different ways to count these. Okay, obviously there's five squares. Now they're just saying I can go one, two, three, four. So I can count the row first. Row there's four, and then up one. The equivalent of that, it's in other words the same thing. Equivalent. I can count down, so I can count down two, and then to the left, one, two, three. So one, two, three, four, five. So down two, left, three gives me a total of five. This gave me a total of five. I get the same answer no matter which way I do it. Same with these. I can count this one first, this one second, then this, or I could just start from top to bottom. Just different ways of doing the same problem. Okay, let's see what they got here for an example. Suppose you are planning an event that will require renting tables and chairs. The tables are to be arranged in one line with the sides of the tables touching and the chairs placed on all available sides. We will assume the tables are square and can fit into one chair on each side. The first few arrangements are shown. So they got one, two, and three tables. And I'm just going to go to the next page to make sure they don't have go on here. So I'm going to have to use this picture to answer number two. Okay, complete the following table by determining how many chairs can be accommodated for each number of tables and writing an expression for n tables. Okay, so here I have a number of tables. There's one number of chairs. I can put one on each side. Gives me four. If I have two tables, put one on each side. So I got one, two, three, four, five, six. Three tables. Let's see. Here's three tables. One, two, three, four, five, six, seven, eight. I bet you four tables. I'm probably going to have, yep, you guessed it, 10. If I have 20 tables, well, five will be 12, so I'm not really sure. I'm going to have to like, come up with. It seems like I'm just adding two when I add one more table. Or here's an even better way of doing this. Let's see, I have, if I multiply this by 2, I'm just 3 times 2 is 6, and I add 2, I get 8. 4 times 2 is 8, I add 10. 20 times 2 is 40, add 2, I get 42. 200 times 2 is 400, add 2. So I have n tables, multiply it by 2, and then add 2. So that's just one way. There could be other ways of doing this. That's the one I happen to notice. So if I look at their little table down here, they actually have 4 different ways to come up with the general formula. You could take 4 times n, sorry, 4 times the number, and then subtract. Well, take that number minus 1 multiply. That seems pretty involved. I don't think I could do that in my head. This is the one I did. N plus n, or 2 times n plus 2. Here's another way of doing it. I mean, the easiest one for me was 2n plus 2. They have some common verbal phrases. 2 more than a number is you add 2. Twice as much, you multiply it by 2. All but 2, you have that number minus 2. 2 less than a number, same thing, n minus 2. 2 less a number, okay? So that is your multi. Be careful here. These two are really tricky. Okay, 2 less than a number. So I got my number and I want 2 less. Here, I want 2 less a number, so you actually have to switch these. Remember, these are not, division and subtraction is not communicable. Communicable. Twice a number, half a number, you're going to take n times 1 half. Okay, 3, simplify each expression. We know how to do this because we did the distributive property. I'm going to do this step by step. 4n, I'm going to distribute the -2 over the parentheses. So I get 4n minus 2n times n is minus 2n. Minus 2 times minus 1 is a positive 1. And if I simplify all that, combine like terms, 4n minus 2n is 2n plus 1. And here, I have 1n plus 1n. It gives me 2n plus 2. Notice that's the one I use. 2, distribute, positive 2. I get 2n minus 2n. I'm sorry, 4 plus 2 times 3 is 6. I get 2n minus 4 plus 6 is a positive 2. And again, same, oh, this should be a 2 up here. Like, eeks. These should all be the same. And then the last one was 4 plus, since I have a plus 1 in front of the parentheses, I just drop it. 4 plus n minus 1 times 2, follow PEMDAS. I have 4 plus n minus 2, which equals n plus 2. What happened here? I should have got a 2. I think they made a mistake somewhere. Oh, I forgot to distribute. See, they tricked me up because they put the 2 after the parentheses. So there should be a 2 on here. Ugh. So used to seeing it in front of parentheses myself. Okay, let's consider another way of arranging the tables and chairs. Just discuss. Assume the tables are arranged in a plus shape as follows. Okay, number of tables with 0 chairs. Use the following table to determine each thing news information. Assume tables are in plus sign. So, number of tables with 0 chairs. 0. Number of tables with 1 chair. No, oh, my fault. This middle table has 0 chairs, so it's got 1. Number of tables with 1 chair. Let's see. 1 chair, 0. It either has 0 chairs or 2 chair minimum. Okay, number of tables with 2 chairs. Okay, so I'm thinking to myself, this doesn't make sense because in the previous problem, we had a consistent system here where it was linear. And this is not linear because the numbers for 2 chairs, for 3 chairs, and so on is not consistent from this figure to this figure to this figure. So they made a mistake here. We cannot use this table for if we want to include all figures. If we just take one figure, we can do it. So, yep, let's skip it. Bad them. All right. Your neighbor is building. Oh, this is an example with the solution. Oh, that's okay. I'll talk to you. A neighbor is building onto a square patio. He plans to add 5 linear feet to both the width and the length of the patio. He claims that the patio will then be 25 square feet larger. How do you know he is incorrect? So listen, since we don't know the current size of the patio, we can assume it's X by X feet. True. There's a square patio. We know all sides are the same length because it says square. And he wants to 5 linear feet to both the width and the length. So here I'm going to add 5 feet, and here I'm going to add 5 feet. Now, he doesn't say whether it's for all sides or if it's just for one side. I'm assuming he just wants to add. This is 5, this is 5. Okay, so he claims the patio would then be 25 square feet larger. How do you know he's incorrect? Because each side then, this side becomes x plus 5. This side becomes, it's just x, whereas this side becomes x plus 5. It's not equivalent to, so the area, total area, is going to be x times x plus 5. And since it's a rectangle now, not a square, we go ahead and distribute x squared plus 5x. We can see that x is not equal. Oh, here. If he adds 5 feet in each direction, the patio will be x feet. See, now they changed. See, they changed it. They said each side. Each side, we're going to add 5. Wish they would be clear from the start. So this is all wrong. And now we have an area of x plus 5 times x plus 5, or x plus 5 squared. Is this equivalent to x squared plus 25 as he claims? No. We can simplify to find out. If we FOIL this, we get this, and that's not equivalent. So this is x squared plus 10x plus 25 does not equal x squared plus 25. And again, since it includes the extra 10x, see, we don't have this term. There is none on this side. That's the difference. There's no 10x. These expressions would be equal only if x equals 0, so your neighbor is wrong about the new patio being 25 square feet large. The patio will increase by more than 25 square feet. Now, this whole problem is based on the fact that they didn't tell us in the original problem whether they're increasing every side by 5 or if they're just adding a 5 by 5 area here. It makes a big difference, even in their conclusion. They still didn't tell us. So either one could be right, but they are different. This is a really bad example of it because they're not clear. Okay, let's see if this happens on problems. Which of the following expressions are equivalent? If an expression has no match, write two equivalent expressions for it. So I'm going to combine like terms. I'm going to simplify all of them. This one simplified. 2 times 2x squared is 4x squared. 2 times minus 2x is minus 4x. 2 times minus 1 is minus 2. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is positive 4x. Negative 2 times positive 3 is negative 6. Combine like terms. Let's see, nothing combined there. I get 4x squared minus 4x and plus 4x cancel out. Oh, here's an x squared term. So I need to combine these. 4x. So this is a 2x squared. Okay, and then I have a minus 2, minus 6 is minus 8. Next one. 2 times 2x is 4x. 2 times minus 1 is minus 2. 3 times x squared is 3x squared. 3 times negative 2x is minus 6x. Minus x squared plus 2x minus 6. Combine like terms. I have a 3x squared. 4x minus 6x minus 1x is negative 3x plus 2x is minus 1x. And minus 2 minus 6 is minus 8. 2x squared minus 8x plus 14. That's simplified. X squared minus 2x minus 2 plus x squared minus 2x plus 9. Let's see, 2x squared minus 2x minus 2x minus 4x. Minus 2 plus 9 is a plus 7. Let's see, x squared minus x plus 1 distribute plus x squared minus 3x plus 6. Combine 2x squared minus x minus 3x is a minus 4x. And then plus 1 plus 6 plus 7. So these are equivalent. 2x squared minus 4x plus, oh, this one's equivalent with that. 2x squared minus 8, that's not equivalent, and we're supposed has no match, right? Two equivalent expressions for it. Let's see, these do not have a match. Oh, wait, what's this? 1, 2, 3. Okay, so write two equivalent expressions for it. Well, here's one. I could take out a 2. I need two equivalent expressions. So 2x squared minus 8, I need 2 equivalent. So I could take out a 2, x squared minus 4. There's 1. I could also factor that. 2 times x, because it's a difference of squares, x plus 2 and x minus 2. Okay, so there's 2 equivalent expressions for that one. Let's see, I have 3x squared minus x minus 8. Let's see if this factors. I'm going to do separate sheet of paper here. See, I got a 3x and an x. Minus 8, so what if I do minus 4? Nope, 4 and 2 don't work. 1 and 8's not going to work. It doesn't even factor here. Right, so I better check this, make sure I did it again. Minus 6x, 3x squared, 2x. Oh, there it is. There's my mistake. Okay, this should be a minus x squared. That makes more sense. So this 3x squared minus x squared is 2x squared. Okay, so negative 6x, positive 4x, positive 2x. There is no, wipes it all out. And a minus 8. So these two are equivalent. Wow, I just did a whole lot of extra work. Let's see, this one does not have a match. So I need to match 2x squared minus. So I need these two. So I have 2x squared minus 8x plus 14. Well, we know that this is an equivalent one. So 2x squared minus 4x plus 7. Let's see, can I factor this? Nope. I could use the quadratic formula. Let's see. X minus 7 minus 1. Nope. Well, I would say for you guys, this would be good. This is two equivalent expressions. I could go on here. I could do completing the square, use the quadratic formula and get another one. But I'm okay with these two. All right, that should be it for 2.8 before you do your homework.